So hi everybody. Today we're going to talk about how you can accelerate the development of SaaS services in your organization. I'm going to show the automation that we've built at CyberArk that allowed us to reduce the time to production for every new SaaS service by 18 weeks. Yes, you've heard it right, 18 weeks. But before I do that, let me quickly introduce you to what we do at CyberArk. So CyberArk was founded about 25 years ago, 1999. We have over 3,500 employees across the globe and over 900 developers. We're a cybersecurity company, and we're leaders in two main domains, identity security and access management. And over the last couple of years, we've become a serverless first SaaS provider. And that's where I want to shift our focus to, being a serverless first SaaS provider. So about 5 years ago, we started to build this SaaS framework, all the services, started to build this SaaS control plane, and we started with the first service, the tenant management or the customer onboarding service. And it took us some time to really understand what it means to be a SaaS provider and how to build it. But at some point, we reached a reasonable maturity level for this new service, and we started to build the next service. So we realized, okay, we did one service, that's great, but we have so many other services to build. And even then, across the organization, other teams wanted to integrate with our new SaaS platform and build their own serverless services. So now we had other challenges. So how do you adopt serverless across the organization? How do you keep the standards that we've built from the first service and keep the same standards? How do you use the same tools for observability? So we have a unified language to debug our customer requests across all the services. And most importantly, how do you replicate it and do it quickly? So for that purpose, we built an automation. And this automation has been used by hundreds of developers. It has created dozens of microservices and services across the organization. It has reduced the time per new service by 18 weeks. And in overall estimation, it has reduced the time to market across the organization for over a year, over multiple years. So today I want to talk about what it takes to really build a production-ready serverless SaaS service. We'll go over the components and see what makes it really a production-ready. Then I'm going to show the developer experience for our automation that we've built, how the magic looks like. Then I'm going to introduce you to the concept of blueprints, and then we're going to see the automation under the hood. I'm going to see how it really works. And lastly, I'm going to give you some homework in the form of action items. So before that, I want to quickly introduce myself. My name is Isenberg. I'm a principal software architect at CyberArk at the platform engineering division. I've been at CyberArk for over 7 years now. I'm an AWS serverless hero, and I have a website called roundthebuilder.cloud, number 9, where I talk about all things AWS and serverless. I have technical blog posts and videos and AWS.com articles. Okay, so let's build a SaaS service and make it production ready. So usually when I look at a service, I think about it as opening a Pandora's box. It can be sometimes a monolith that you lifted and shifted into the cloud, or in some cases, God forbid, Kubernetes-based. But in most cases, most modern services, they are actually built as a composition of microservices, right? So it's a composition of microservices where each one has a single responsibility of its own domain. It can scale on its own, and it's decoupled. So you can build it as an isolated a microservice, and it has a concrete contract and its own API, and this is how it works usually. So basically what I'm asking here, what it takes to build a production-ready service, the answer is really, the question is really, how many production-ready microservices do I need to build, right? What does it take to build them, basically? So I want to build a hello world service, which is a composition of lots of microservices. So for me, coming from a serverless world, it's usually something like this. an API gateway, a CRUD API. You have an API gateway, Lambda function, and you save information to a DynamoDB table. That's usually the regular hello world template that we're using. Now, I've created an open source version of this template. I have a GitHub template that creates this full microservice with all the best practices. Now, if you miss this QR code, in the end, I'm going to have a QR code with all the links that I'm going to share here. So this is the basic backend microservice, but is it really production ready? No, not really. In order to be production ready, we need to think about 5 aspects: infrastructure as code, CI/CD pipeline, Lambda best practices, testing, and unified observability. So the infrastructure as code, for us, it's CDK, but you can obviously use also Terraform and other frameworks. It creates all the resources. It's maintained by the developers. We advocate for DevOps culture, where developers also change the business domain and the infrastructure as code. And you have built-in security and governance tools into the CDK code. So for instance, we are using, you can use CDK NAG, which is an open source utility that scans the CloudFormation output before you deploy to AWS and make sure that you have no misconfigurations or other security issues. Now, as for security, you also have WAF, the Web Application Firewall, that you need to associate to your API gateway to protect you from DDoS attacks. CI/CD pipeline should be there, obviously, and it should basically have all the tools, all the linters, all the security scanners. It should do the AWS deployment, run all the tests, and basically take you from PR to production across multiple environments: dev, test, stage, production, and also multiple regions. Now, when we write the Lambda, the Lambda itself, it should basically use the best practices. So hexagonal architecture, for those who don't know, it's a layered architecture. So you have the handler layer, you have the logic layer where the business domain resides, and you have the data access layer where there's the interface that interacts with our DynamoDB table in this instance. And we also need to think about security. So we need to think about input validation, authentication, authorization, tenant isolation, where we are saving customer data in our table, right? But we need to do it in a secure manner. So again, we're doing a lot of work here just to make a very simple hello world microservice to make it production ready. Now we also need testing. So it's unit tests and integration tests with AWS, and end-to-end tests where we actually execute the APIs the same way a customer would, and it runs on AWS. And lastly, we need to think about unified observability, where we can actually debug our customers' requests. So we need to add logs, CloudWatch JSON logs. We need to add traces to have integration with Amazon, with AWS X-Ray to do performance benchmarks. We need to think about CloudWatch metrics to monitor our services, or maybe custom CloudWatch metrics for KPIs. We also need to have alarms to set thresholds on our metrics or logs. And lastly, we need to have dashboards that visualize all these elements together. So again, our very simple backend microservice needs all these elements, all this work to be production ready. But it doesn't stop there. We also need the UI. We need a front end, right? We need our customers to see the data. So a hello world microservice for this instance would be a table that fetches information from the backend and shows us the information in a table from the DynamoDB table. So in our use case, we're going to use an Amazon CloudFront distribution and an S3 bucket that holds React or Angular static files, and the CloudFormation knows, CloudFront knows how to distribute the data between the API gateway or the bucket. But here again, we need to think about 5 aspects to make it production ready, even though it's just a simple table that fetches information from the backend or writes information to the backend. Infrastructure as code, CI/CD pipeline, front-end best practices, testing, and telemetry. So here again, we need to use the infrastructure as code to deploy the CloudFront distribution, to create the S3 bucket, to upload the React files to the bucket, and then think about security and governance as before. Again, so the CDK NAG, and this time the Web Application Firewall will protect the CloudFront distribution. The CI/CD pipeline is the same as before. It runs tools, linter security scanners, but here it's going to be probably a different language than what we did for the backend, and it needs to get us from PR to production. Now here, for the best practices, we need to build our elements in the modular components, so they're reusable and we can test them in an isolated manner. We need the integration with the backend API to see that we can fetch and write items to the DynamoDB table. We need to think about security. Login flows, refresh token, logout. We need to think about caching, performance, accessibility, proper error handling. Again, a lot of work for just a simple table to get information from a DynamoDB table. I'm testing, again, unit testing, component testing that run in the local host, end-to-end tests. We can use Playwright, Cypress. We need to think about different client configurations, mobile clients, different resolutions. A lot of work here again. And lastly, at CyberArk, we also use telemetry. We use mixed panel so we can trace the user actions in the UI, so we know which features we need to develop, which features we can stop developing. So again, we need to integrate with this mixed panel SDK. So again, 5 elements to make it production ready. Does it stop here? Not really. Usually you need at some point to integrate with the SaaS control plane. So at CyberArk, this usually means that we need to connect to the tenant management service. For each service, we have our own domain, our own DNS domain for API calls, so it's myservice.cyberark.cloud. We need an HTTPS domain. We need cross-account access. Sometimes you need to subscribe to an SNS in a different account. You need your SQS to subscribe to get messages. Sometimes you need to do role delegation, where you have a role in your account, it can assume a role in a different account to access a protected API gateway. So what I'm trying to say here is that production is complex, and it takes more than one microservice. You need multiple microservices. You need integration with other services, and you need to do it across multiple AWS accounts and sometimes even regions. So we estimated for us at CyberArk that this work for a veteran team would take about 18 weeks from scratch. It's a lot of time. So this is why we basically automated this part and turned it into 3 hours. And this is what I want to focus now. I want to show you the magic. So let's see the developer experience of using the automation. So it all starts at the developer portal. We're using Port, which is a SaaS service. And you can see here the self-service hubs, this section here. On the right, you can see the business service. We want to create a new business service. We click it, and we have this form. So for our example, let's say that we want to build the one-click service. Okay? Remember this name. So we need to choose our GitHub organization, our service enum ID. That's the enum that is going to be passed around these APIs in the SaaS control plane. Our service name, that's the display name, the service name that the customer is going to see in our SaaS UI, the CyberArk SaaS UI. Our service subdomain for the DNS, if you remember, we need to register a DNS subdomain. And the team that is going to create this service. Then we click on execute and the magic begins. So basically what happens is we create all those microservices with all the best practices that I've mentioned before. In our case, three microservices turned into 6. So we built those 6 microservices. Their GitHub repositories, their Jenkins pipeline with Jenkins. And then after 3 hours, because we deploy them to multiple environments on AWS, one after another, because there's a dependency between them, everything is created. And now all that is left to do is basically log in to the SaaS framework, to the CyberArk UI, and see the one-click in action. So when we do that, you can see on the left, you can see that we have now one click in the application picker, and this application didn't exist 3 hours ago. And here, you can see the table, our UI microservice, that loads information from the backend, from the DynamoDB table. So basically, everything here is working together. SaaS control plane, the front end, and the back end. Again, 3 hours instead of 18 weeks. So if I need to summarize it, it's basically self-service, serverless automation, and we're going to touch why it's serverless in a moment, for creating a serverless SaaS business service using blueprints. So I'm going to discuss blueprints in a second and clarify this point, but it's a very important distinction. So what we've seen is 6 microservices with GitHub, with the GitHub repository and their Jenkins pipeline, deployed to dev, test, staging, and integration, different AWS accounts. And on integration, it's 2 different regions. It took us 3 hours. That's because there's an AWS CloudFormation limitation. Now, from the developer side, all they need to do is basically extend these new microservices and start writing the business domain. That's it, right? Because it's already in the SaaS control plane. They already have something working. Just go ahead and extend it. Right. So blueprints. I want to make this clarification. So blueprints are basically a microservice starting point. It's a GitHub template repository that has all the magic sauce, right? All the best practices, all the tools that we've mentioned here. Developers, they just start from there. It allows them to focus on the business domain, it reduces their cognitive load, and they don't need to reinvent the wheel. All the elements, all the best practices are there. Now, from the organizational side, governance is great. Everybody's using the same tools, everybody's using the same best practices, and everybody's using the same observability tools. So, in my example, we had 6 blueprints, which are 6 microservices. Again, it's not really important why 3 turned into 6, but it did. Okay, so I'm now going to share with you some secrets and show you how it really works. So I think in the end, you have the developer portal on the left. It starts the blueprint orchestrator, which deploys the blueprints. And then one of the blueprints is a special blueprint. It's a blueprint that automates the SaaS control plane integration. So the VETL, as I mentioned before, we're using Port, which is a SaaS service. It provides us with the form with parameters, and it triggers the orchestrator via Kafka API, and it shows us the status and logs as the work goes on. Now, the blueprint orchestrator is serverless. It's a step function state machine with Lambda functions as steps. It calls the Jenkins, GitHub, and Snyk APIs, does all the magic connections that we need to do. And then it creates the microservice from the blueprint, from the GitHub template, runs the Jenkins pipeline. When everything finishes the deployment to the 4 AWS accounts, it goes on to the next one. Now, as for the blueprints, again, these are the microservice repositories. They run the CI/CD pipeline, deployed to AWS, multiple regions and environments. But one of those blueprints is very special. It's a SaaS control plane integration. Now, this blueprint leverages another serverless service. It's called AWS Service Catalog. It basically allows us to deploy CloudFormation versioned templates across the organization. And what it does, it triggers a serverless automation that does the cross-account access. I'm going to show you this in a second. Now, this is the most complicated slide here, so I'll do it slowly. But I want to make sure, but please be aware that I've open sourced this entire solution. It's in the QR code here and also in the end. So if you want to understand how it works, it's CDK fully working. It's in the QR code. I've also written an AWS.com article about it, and next month I'm going to go on a deep dive on the AWS Developers Podcast, where I'll explain everything in detail. Okay, so what is our goal here in the end? We have on the left the one-click AWS account. It's the account of our new service. On the right, we have the SaaS control plane. Our goal is to have role delegation. So this role here on the right, the IAM role in the SaaS control plane, has permissions to trigger a protected API. We want a role on the left to be able to assume the role on the right, and that way to have the permission to access that same API gateway. So the way we do it, our Jenkins basically deploys a CloudFormation template from Service Catalog. It's called Provision Product, but in the end, it's a stack. So we deploy this stack, and this stack creates an IAM role. And then this is the role that we're going to use to, from this role, we're going to do the assume role. Then it creates a special custom resource. It's a CloudFormation custom resource. It has an input and an output. The input is the IAM role ARN that we've just created. The output is going to be a message, SNS message that we're going to send to the SaaS control plane containing this ARN that we've just created. So that's what it does. It sends a message to the SaaS control plane, gets to an SQSQ, then triggers a Lambda function. Now, the Lambda function has on one hand the ARN that we've just created. On the other hand, it knows the ARN of the SaaS control plane. So now all it needs to do a simple Amazon AWS SDK call and make sure that the role on the left can assume the role on the right. That's a basic trust relationship API. So that's what it does. And now we have basically granted the cross-account access in an automatic manner. Once it does that, the Lambda function releases the CloudFormation, the custom resource from its wait state, deployment is completed, and voila, we have cross-account access fully working in an automatic manner. Like I've said, I've open sourced this solution, and there's a blog post that explains really in depth what's going on here. Right, so developer portal, blueprint orchestrator, blueprints, and the SaaS control plane integration. Great, so homework. Let's talk about action items for you guys. So if you haven't paid attention, you should definitely build blueprints for your microservices. We started with one blueprint, then you add a self-service for that one, then you add more blueprints, and then you add a developer portal to make things much easier to use, and then you build automation where you orchestrate multiple blueprints. And then obviously I recommend it to use serverless services because it makes everything much easier and simpler. So everything that I've mentioned is in the QR code, and even more articles I've written on AWS.com that shares information about what we've done here. You can follow me on these social links and my website, runthebuilder.cloud. And thank you.